Okay, let others can join. Okay, sorry, my apology. I forced you to join the classes for the late evening hours due to some examination schedule work. Okay, you are well aware that we are having a curricula on fluid mechanics for the second paper that shows that in different parts. The one of the fluid mechanics and dynamics both are together. They are there. The first unit is taught by our colleague Professor Shushila. She might have covered a good amount of syllabus right now. Okay, what we mean by fluid mechanics? Why we need that type of things in our curricula? What is the purpose of it actually? It all depends on its applications. It also depends on the great opportunities for the problems to be solved by for several applications actually. Fluid mechanics is a branch. We don't call it with only in mechanical engineering. This also lies with the physics and also the dynamics part of the page. On the left side, I wrote it this because this subject is good for all bright students who joined our department and undergoing a course in MSc in Physics of 2022 batch of Bangalore University. Here, what it is shown in the diagram, simple diagram, no much complexities. A bottle of water is poured to a glass. Of course, if you are having a water in a bottle, the empty glass go on filling with the water till it gets filled up, provided the volume of bottle is more than that of the volume of the glass. Glass means in the sense measuring jar, we can call actually. Let us assume we are drinking water. What is the beauty? Why we have to study this type of things actually? If water is allowed to fall or flow through a bottle, it will be transferred to the container, which is shown on the right side, right bottom side of the test. Means, if we know this, maybe we can study the mechanical properties, we can study the dynamical property, we can understand the properties, how it has to be transferred from one system to another system, maybe a bottle to a glass, or maybe a glass to a bottle, or vice versa. In the meanwhile, whether we have a loss, how that flow has to happen. Whether the flow should be in a linear flow, they will call it as the laminar flow. Whether it should be a turbulent flow because of some turbidity, and whether it is invisible or maybe not visible. Whether all kind of fluids can flow from bottle to a glass or maybe a jar can call. Can we apply the same thing, same rules, same mechanism, or similar concepts either for the water, for the alcohol, for the oils, for the tar, rest of the body. This is a good, beautiful example. On the left bottom corner, you can see that this is a big ocean. Maybe seeing the wavy natures inside that at least. The waves are also perturbing the phenomena to a great extent where you are how to study the dynamics and mechanics put together to understand the fluids. On the right bottom corner, I put that those who like the spirit, of course, in chemistry, the spirit is known for an alcoholic liquid or maybe fluid of that kind, preferably in the liquid form, either not benzene, either ethanol or even methanol or any kind of a volatile liquid actually. Because even though people like much spirit, particularly in Western countries and even in India too, that would be an asset for them. Here, the word I used, those who like the spirit of understanding the fluid mechanics, understanding the fluid dynamics, understanding the continuum mechanics, understanding the conceptual physics in continuous physics, understanding the computational physics to solve some of the real problems. If you raise the bottle head, where the water will fall from bottle to the glass, how long it will take to empty an 1 liter of can of water? Presume that the dimension or diameter of this nozzle of a bottle may be about 1 inch, around 2.5 centimeter. If the water flows, it may take few seconds, about 10 seconds, maybe 12 seconds, depending on that. If the air gets blocked, if air does not allow, if the pressure inside the bottle and the pressure outside remains constant, then the situation may reach in such a way that you may reach an equilibrium, water may not fall at all. Whether you have witnessed it or not, we'll see later. Means follow it. Means that whether whichever may be the size of the bottle, whichever may be the size of the container, can you expect that same amount of energy will be transferred? Whether you take about a 2-inch diameter or 10-inch diameter or about 20-inch diameter, can it hold the same amount of energy what we can have? It means to say that if we keep a water bottle on a glass sheet, okay, water bottle may have the diameter of about 10 centimeter at least, okay, 10 to 12 centimeter to a great extent, okay, 1 liter bottle of that kind. Can that glass sheet withhold the entire mass? Instead of that, let us spread the same water on the table with about 2 thickness and spread it to the entire table. Can it withhold? Means to say that how that energy can be transferred from one to another phase, or how that energy can be dealt in the nature. It is not an easier job. Clouds are floating, clouds are moving from one point to the another point, both vertical as well as the horizontal. If you estimate a mass of a cloud, it comes to be several thousand tons. Can you have lift several thousand tons of mass into the air? Because to lift a rocket of several kilograms, maybe about 1,000 to 2,000 kilograms, people will spend huge amount of energy in terms of burning the fuel at the cost of several hundred crores. Clouds are forming on their own. Clouds are precipitating on their own. Clouds are also the composition of water vapor in its different forms, means to say maybe with the different decompositions, particularly in terms of the size and the number to a great extent. Means the fluid mechanics is very brilliant subject. A fluid mechanics is a very relevant subject to be understood in a better way by the physicists compared to an engineers from mechanical branch, okay, compared to an another mathematicians who are working on the models, compared to an another discipline like computation, fluid dynamics. Computation is only in terms of the theoretical part of it. We will see one after the other actually. I hope you will enjoy. There is no way. You will also enjoy this in such a way that this is highly and high order mathematical tools are involved to solve the problems in fluid mechanics. Mechanics is nothing but movement of an object, or maybe either in the form of a solid or maybe liquid or maybe gases from one region to another region. Thereby we can estimate its time derivative, thereby we can estimate its space derivative, thereby we can estimate the either position, momentum, and rest of them. Of course, if you expect that the energy should consist in all the parts. Here we are saying the fluid mechanics because fluid is a common terminology used for understanding the behavior of characteristic properties of either liquid or gaseous put together. Both liquid and gases together are called fluid. Liquid may not be a fluid. Gas is also a fluid. Maybe fluid means need not be a liquid alone. Fluid means need not be gas alone. Gas is a part of a fluid and water is also a part of a fluid. Liquid is also a part of a fluid. All liquids are fluids. All gases are fluids. For example, if you switch in the sense in the terminology of if you're triggering the if you're triggering the mechanism of putting it on the pipelines in your home to get an drinkable water either from whichever may be the river or reservoir source. If water comes, the meter will show you the some indication that how much water you have taken from that pipeline or from that reservoir. Fine. If you keep that pipeline on, if there is no connectivity for the water, still air will flow. Flow of the air will also gives you some reading because you are not sure that when the water will be released from the reservoir or maybe over a tank in your area to collect the water. Some of the villages, people will collect the water, drinking water preferably, sometimes even late evening, sometimes night time, sometimes very early morning, all possibilities are there. We'll see how best one can should be taken. I'm not exaggerating you. These images are conveying a lot of messages one after the other. How it has to happen, we'll see that. Ha! We are having three pictures. One is that from a tap, water is falling and the glass, inside the glass, what is gets filled up, it flows outside the glass. See that the diameter continuous flow. You can't discriminate that whether it is breakable or not. Even you can think it up, it may be of the ice cube of that kind in the cylindrical form. Water flows continuously and it is coming out of it. The amount of water which is coming from a tap and the amount of water which is flowing out of the glass, whether you can say that they are equal or it should be more than that what inlet or it should be less than that inlet, one should be thinking of. You can estimate, it's not an issue. And here you can see that the water is coming, but not in the same fashion actually. At least you can see the discreteness. Take a right side diagram. A water is poured to a glass, beautiful glass of shape that you can enjoy drinking water to a great extent. People in some countries, particularly the countries or the regions, you can call India can be a country like that to discriminate them from the rich, rich resources like some deserts. Desertorious things actually, European countries may not find drinkable water. The areas are surrounded by ocean to a great extent. In the flight or in the regions, they will say that you just drop or you get a break there and have enough water to fulfill your thirsty and no need to pay for the drinkable water. Means you are paying about 20 rupees per liter. Sorry, you are paying about 20 rupees per liter for water, almost, and 20 rupees for half liter for milk. Means that such an expensive think it has to be heaven. Means even though the India, country like an India, is covered by oceans on all the sides, three sides, it's called as the peninsular India. But as far as the drinking water is considered, we don't have such an high enriched resources for that drinkable water. Once it is collected, then we use it for some time actually. See that, means something like a cucumber and other things they have put, it is rotating, water is falling continuously. Can you estimate that actually? Why? Whether it gets cooled down or whether it gets warmer, whether it gets can change its properties when falling from such a height of about some 10 centimeter. If it falls from about a 10 kilometer from the cloud to the earth, can you expect that the property of the water will remain as such as a water? Or can it get contaminated with the minerals which are available? Minerals you can call contaminations which are available in the environment like sulfur dioxide, carbon monoxide, carbon dioxide, some soot particles. What will happen to the properties if it goes inside the earth crust? Can you expect that the due to the sedimentation and other things, water gets mixed with the innumerable number of the menus, large number of variants like iron, like copper, like nickel, like aluminium, even the hazardous materials like an potassium, then that water we are using as a drinkable water from either well or from the bore wells or from rivers without making the filtrations. Like both in village sites and even in city sites, we drink the water, it will not harm us unless it gets stored in your home for about weeks time. Maybe it gets stored in your hostels for few days. You may not find that water. Water gets contaminated actually. But the water in lake, water in river, which will never be gets contaminated, that type of filtration or maybe mixing with the environment to attain its own property has had its own beauty. Water you may not get it from only 1 or 2 days. The water was formed or the formation of water has happened almost some 2.5 to 3 billion years ago when first lightning struck the earth and then the temperature of the earth was come down to the temperature what we expect actually. There were several rains that several rains made the oceans. Those oceans made the formation of or evaporation of water as in water vapor and formation of the clouds, and the movement of the clouds have maintained the temperature in such a way that the regions for the entire globe was cooled to the normal temperature or maybe an average temperature that is sustainable for the life to exist on the earth. Being this, see an image. We want to study. A drop of water is falling from the tap. A drop of water has fallen from some height. We would like to understand the properties, whether it is a spherical or non-spherical, whether what should be the volume, why it has to drop, why can't it stay and isolated actually. If a drop falls actually, how much energy it can possess? Why can't it fly up? Why can't it move on horizontal? Either you take an example of an isolated droplet of an water or isolated droplet of any of the liquid and make the analysis and extend that analysis for the entire sample or maybe voluminous material of that kind. This is a beautiful picture captured by a very good photograph. You try to get this type of a photographs. You'll see that in your free time, just allow the water to fall from your glass to the floor or maybe to a container and try to capture the photos in such a way that are you able to trace, are you able to track a dropping of a single droplet? See that? Fantastic. Becomes detached and this becomes several drops. See that several drops coagulated, mix it together and makes the formation of an one single drop or huge drop of that kind. While leaving one bigger drop in between, narrow, it cuts down. There is no continuity. Several few 8 to 10 drops becomes single, maybe only 3 droplets. Okay, but when rain comes from the great heights like and clouds from 8 to 10 kilometer height, tiny droplets in the form of an water vapor will coagulate, can combine together and will fall to the earth due to the gravity. While falling down, they will mix in the sense they will interact with the molecules and the drop size goes up and it becomes an tiny droplets becomes an water drops. What you are getting as the rain on left side. See, it is hectic like that, like almost sheets, like a tips, okay, which are falling vertically. Have you experienced at any time that always you will get a rain vertically downward, or is it slanted? Imagine a person who is sitting on the chair receives the rainfall, who is sitting under the umbrella. Okay, what droplets are falling very vertically down. Can you imagine if water falls continuously? Can your umbrella can withstand such a force? If not, it is the form of a parabola downward. Actually, whichever with the droplets which falls will be slided over. Actually, if not, if you can keep a glass sheet, can you expect that the glass sheet can bear that force, or it may break down? Means here, see that things are falling. To understand, we need fluid dynamics, we need fluid mechanics. How it has to happen? Being this. The first semester, we're having a curriculum for the fluid mechanics, particularly in the second, not particularly, in second unit alone, what I'm going to teach you in few classes. Okay, the broadly can classify that into 8 topics. Some topics may take quite long time to discuss. Some of them can be discussed in about 45 minutes to 1 hour, no issue at all. Newtonian fluids, my God, you might have expected the fluids of water. Water is a fluid. Maybe kerosene is a fluid. Kerosene is a fluid. Hydrogen is a fluid. Nitrogen is a fluid. Newtonian fluid. Why that fluid is called the Newtonian fluid? Is it the Newton is an owner for the fluid? No. The Newton has developed some theory to understand the movement of fluids or motion of fluids, preferably the liquids to a greater extent. And he gave a theory, and for those theories, we are calling them as the Newtonian fluids. Maybe flow of water in a river, flow of water in a canal, flow of water in an ocean, or formation of the waves in an ocean, or maybe flow of water in pipes of different shape, or maybe falling of rain from top to the down. Of course, you can't get it up. All these things are the examples for the Newton fluids. Starting from topic 1 to the topic 8, the topics deals with the Newtonian fluids. Last two fundamentals of non-Newtonian fluids are also there. Non-Newtonian means it is not against. Some of the fluids does not obey the criteria laid down by the Newtonian. Those kind of fluids are known as the non-Newtonian fluids. Will not deal much with the non-Newton fluids in your syllabus. No, they are also very good examples for the understanding the fluid mechanics and dynamics to be there. But compared to the Newtonian fluids, non-Newtonian fluids are having a complexities in understanding the phenomena that we will see later actually. Means Newtonian fluids are the one, we'll describe one to the other, or you can refer any of the textbooks or any study material, is not an issue. My intention is that in such a way, if you are trying to understand this type of fluids, you should enjoy the theory behind it, concept behind it, efforts behind it, and how you can able to break it. Means based on that, you can also have the flow for some kind of a liquid, viscous flow or non-viscous flow. Viscous flow or particularly viscous compressible flow. Fluids can be compressible. Yes or no? You think it of. Means, see, for example, if you buy 10 kilogram of wheat flour, for example, that may occupy a position of about some desired volume. Can you compress it and can fill it still more? No. And if you buy and 1 liter of water and transfer that to a jar of 1 liter, means can you add some more water to a jar of volume 1 liter where it can be stored still more water by the way of compression? Think it of. Then equation of continuity or continuity equation also they will call actually. Like mass is conserved, energy is conserved. We having an equation for the continuity. Liquids will never change. The things they may change from one phase to another phase. Some of the properties are conserved. Those conserved properties will try to understand through certain laws, through certain mechanisms actually that gives us a better understanding of the properties of the fluids which are where we are observing in our day-to-day life. And the flow of a viscous fluid. Flow of a viscous fluid and viscous compressible flow, they differ actually how these viscous fluids will flow from point to a point. Okay, maybe flow of a river in a mountain, flow of a river in a lake, flow of a river in an ocean, flow of a river means there is a flow of a water, we can call flow of a water in summer, or movement of clouds, or flying of clouds, or even you can think it of the working of an engine, okay, with the fuel like an either petrol or maybe a diesel, or maybe working of some engines like an aircraft engines. Okay, how it has to happen? Why does such a highly compressed pressure gives us the energy, vast amount of the energy that can be used to move or rotate the mission in such a way that the aerodynamics can be achieved. Now, all JCB missions or some kind of high-end missions, and vehicles are working on aerodynamics. Means the brakes they will apply through aerodynamic brakes. Even two-wheelers are also having an aerodynamic brake. If you having a vehicles with where they can be brought to the rest by applying the brakes with physical brakes, where the tires may go bad at very soon. Means if you are having an aerodynamic brake, that works in a better way. Some equations they can call. Navier and Stokes, both are the great scientists actually. Navier and Stokes equations will try to work it out and its solutions. And their solutions they can call for the case of flow of a fluid, particularly through a cylindrical pipe. Then one more scientist concept we will try to understand the Poiseuille formula for understanding the movement of the fluids. Then there are two kind of a mode or two kind of fluids they can call ideal flows and rotational flows. Ideal flow is a linear or maybe a turbulent. Rotational flow of water bodies in a river and such type of things. The last may not be the least, we'll try to understand some fundamentals, some basics of non-Newtonian fluids. We'll see one after the other. I will not make you scared with the theory part of it for today at least. Okay. My gosh, I don't know how you see the image in your display, smaller display of your mobile. The left one is the drop of water. Try to collect a single drop of water. Is it possible? I don't know. On the right, you can see that maybe isolated water drop, you can see that, which is jumping from the surface, moving upward, and it gets cut physically and becomes an isolated drop. It may not stay there for quite longer time. For a capture through an high-end camera with a high resolutions, it has captured a tiny droplet. Looks like a spherical, maybe bulge like an earth actually, but still having some shapes. Okay, here it is elongated vertically. This one elongated further vertically. See the shape, how it is attaining actually. This is a beautiful phenomena. It is not an easy job. Here we are seeing the different shapes of the liquid water. Liquid actually need not be, of course. Let us assume that the water doesn't matter. Okay, can you take the water in a shape whatever you wish actually? Of course, if you put the liquid water, it takes the shape of a container. Fine. Whether horizontally should be horizontal to the surface. Yes, you can't have the shape like that, a curved surface of that kind, or maybe a bulge shape of that kind. Still, it pays actually. Here it says that one drop of water could power about 100 light bulbs using revolutionary devices. This is the research going on nowadays. Means if you take one drop of water and utilize that energy, which by breaking that one drop of water, okay, it can supply the energy for about almost 100 light bulbs to glow for some time. Means such a huge technology, one has to have to adapt. The left side is that this is for the mercury. If you allow the mercury to on a table or maybe on a floor, on a glass sheet, it always occupies the shape of spherical shape. Here also it appears to be spherical, there is no doubt, due to the gravity. If it is in the space, there is no doubt. Space means, okay, it may have a perfect spherical of that kind. It has bulged, look like a disc for you actually, or the photography looks like of that kind. If we try to make this type of shapes or observe this type of the shapes, getting a mercury is a relatively tough task, but it is also an expensive. Don't handle mercury. If we are having some good finds from the chemistry lab, you can visit the chemistry lab and ask them to show the mercury, and maybe they may show you shapes also to a great extent. Okay, if not, at least try to have a single isolated drop of water from a glass. If you allow, just see that how that shape and the structure will be there, how long they can remain in the space. Good. These are four photographs. The top left, yeah, guy is enjoying an liquid. I hope it is water only. It feels him comfortable and he will be satisfied with his thirsty. Taking a glass of water, there's no doubt. In the first picture also, I showed that whatever the water which was allowed or obtained from a bottle of water, how he drinks is different issue. He is capable of drinking, no doubt. If I give a cup of water for you, you will drink if you wish. If not, you leave it. There is no scheme. Assume that after the food, everyone will take the water. Whenever you feel thirsty, you will take the water. What is the big thing in understanding the fluid dynamics by partaking the water, a cup of water, or maybe water? Right now, you are living on a planet where the gravity plays very important role. Assume gravity goes zero, or you go to a place, or you visit a place, or you stay a place where there is no gravity at all. It is impossible for you to drink even water. I'm not saying that you may not feel thirsty. Maybe you are hungry too to a great extent. But thing is that you will not get. Due to the gravity, water falls from bottle to the glass, water falls to the beaker, water falls from the tap, mainly because of the gravity. If there is no gravity, even if you invert, water will not fall. Amazing. Good. That we have to understand. Everyone knows. If you say this type of things to your friends from other discipline, they will laugh at you. Fine. If they laugh and if they does not give the answer for your query, then you should laugh at them at the end of the class because they may not have the concept of the gravity alone. Okay. Here, see the right bottom corner in a pipe, fluid is allowed to pass through. This is an area of A1. The right half is about A2. The cross-sectional area is maybe S1 and S2 of that kind. See that this is the cross-sectional area because of the larger diameter, the cross-section is less and still it has having the same volume. Here, as the cross-section diameter has come down, but the width wise it has both are of the same volume to a great extent. The fluid may flow with uniform flow. As soon as it enters a narrow band, it moves very fast to cover the same area what it was covering here. This is having some theorem that you will see later. Actually. Take the left extreme, left bottom or right top. A person is trying to have the water. You might have heard these stations called International Space Stations, where the astronauts are making so many observations in the spacecraft. Actually, they could not able to get the water, drinkable water. Water may be with them actually because of the zero gravity. Water will never fall. No objects will fall actually. In fact, everything will float. How they will drink the water? If you are allowing the water bottle or if you are allowing the glass of the water above your mouth from the top, if you allow tilt it downward, water has to fall and you will drink. There is no way. Right now, how can you think that? The droplets are floating. He has to suck forcibly. Otherwise, here also the same case. Otherwise, they have to create an artificial gravity. Everything due to the Coriolis force has to be pushed towards the center of the gravity, and they should sit at the center part of the center of the gravity and able to drink the water. See, again a glass of water. In the beginning, I told here a table about 1 meter length, about half meter width, height, whatever you height you expect doesn't matter. Let it be 1 meter height actually. So keeping a glass of water, this table sustains. There is no doubt. Okay. Take the same table about 1 meter, looks like a larger, but the enlarged image, same width, height is about half 1 meter height, so not 1 meter, half meter or about 1 feet height. This bulb one is about 1 kilogram standard mass made up of about iron. Okay, it is standardized by the non-standardized weight and measures agency in the India. That is from Government of India. If you keep 1 kilogram mass on the glass sheet, top of the glass sheet, you will never feel any surprise. Hey, there is no way. Okay, it will sustain due to the force which is acting due to the 1 kilogram mass. Take an aquarium like here for entire surface area and let it be about one feet height. 1 feet height by about 10 centimeter gives you about 1 liter is the volume of water. If it is 1 meter, 100 centimeter, about 50 centimeter, 100 into 50, 100 into 50 is about 5,000. 5,000 square centimeter or cubic centimeter, 5,000. 5,000 cubic centimeter gives you about 500 liters of water. At least you can keep a 500 liters of water bottle on this. If you keep 500 liters of water bottle or 500 water bottles, where that each bottle is about 1 liter, can you expect that this glass will sustain that force? Think of. Here, see an aquarium, you may be enjoying to a great extent in such a way that people are taking the photography, huge amount of the water, shark is moving here to there. Can you expect that the glass plate will withstand the force due to such a type of a huge aquarium? Instead of constructing the dams from the rocks and other concrete slabs, if they construct it from the glass, can it withstand? Both are fluid. Glass is also fluid, there is no doubt, at a given temperature or at a known temperature of that kind. We'll try to discuss it later. Here I am showing different refills. Okay. Here see that the bottom is not covered. If you invert it, ink will never flow down. Gravity will not act on it. If it is not acting, you'll get a Nobel Prize. If it acts still, if it is not falling, fluid is not falling, if you have the reason for that, still you'll get a Nobel Prize. In the sense, how they have made it like that? It is not easier job. If you allow invert your glass with water, certainly water will fall down. Why can't the ink in a refill will not fall down? Otherwise, if it falls, you may never keep pens in your pockets. It may be, ink may be oozes out of it. These type of things, of course, still they are the ink of different dimensions. See that here somewhat with the higher diameter, they have put one lid here. Here there is open. This is also an open. This is also an open. This may be a close. See that here is a close. Sorry, open lid. Ink flows smoothly at the tip. There is no doubt. Even though tip is very small, tiny tip, ink is coming out of the tip where you are making writings and getting any very good marks. 70 to 70, 30 to 30 in internals. A nice message written on a balloon which was flying high up in the sky. It is not what is outside, but what is inside that it takes you to the top. For example, if you feel a light material like an helium, nitrogen, hydrogen, certainly the density of the gas inside the balloon is less compared to that of the density of the gas outside. If the density is less or the pressure inside the balloon is less, balloon will fly up. only for exaggeration. Oh my God. We are studying the fluid dynamics, whether you allow the water to flow from glass to the water bottle to a glass or from glass to the table, or falls like in Hugby Falls, Niagara Falls, or maybe Kashmir Fall, or fall in your near areas. Waterfall, I am saying that actually. Or you can call this, what is that? Job Falls near Shumaga. Water is huge amount of water is falling from top to the bottom actually. Can you expect that rocks will sustain this force? Can you expect that how that mechanism can be sustained without digging into that? See that, my God, this is a beautiful picture of piling up of water. Why can't we make use of this energy to convert this hydro energy to any mode of the energy that can be used for the life to occur? These are Niagara Falls. Some fountains they are made, beautiful fountains. Usually the tourists will go and enjoy the same water. Droplets you are getting fantastic structure. See that either maybe in Dasara or maybe any kind of an exhibitions you can see that. Some fountains will play in such a way that to the music, strength of the music in such a way they will dance. You might have seen, you might have heard how they are making these type of things. Now, fluid dynamics comes into a picture, fluid mechanics comes into a picture. Your understanding should go in a larger way. My God, river is flowing. See the stones here. I will repeat this tomorrow. See the stones. They are so smooth, so shiny, so slippery. My God, think. Oh, left side is with the lava, right side is the sun, the great sun. But we are getting the energy out of it. Maybe you might have seen the rising sun is looking very beautiful. If you wake up by about 6:30 in over Bangalore, or if you wake up after the sun rises, no way, you are missing only that. You might have seen that in different videos. But sunset may not appear as beauty as the sunrise. Sun is not so dull. Sun is not so quiet. It is having a surface temperature of about 6,000 degree Kelvin. Imagine, it's a very active system. Active emits so huge amount of the energy, huge amount of the particles. Some parts are dark in region, some parts are bright in region, some of the curly. These may be people with the astro may explain, okay? This is the lava, this is the faculae, this is the corona, this is the sunspots which are happening. Okay, this is the there also the dynamics works. Here, there also we can work out with the same thing. Instead of calling it as an fluid dynamics, we can call it as an what they can call sorry, magnetohydrodynamics, MHDs. VHD sir is an expert in that. Okay, Professor Vijay Kumar Durmani sir is an expert in that magnetohydrodynamics. Okay, maybe you can ask him or request him to take one class to discuss on the magnetohydrodynamics. It's a good subject. Yeah, see that different things you are observing actually. We are getting radiation from the sun. We are getting the energy from the sun. We are getting so many particles from the sun. But our magnetosphere protects such type of energetic particles. Our Earth is protected by so many energetic radiation. Still, we are living on the Earth safely without any doubt. Now, I assure this may go also an end. Okay, try to understand the phenomenon in similar